Hello everyone. Clearly I came here for chocolate, right?
Milk or dark?
Dark chocolate, please, yes. But really, I wasn't really given a choice, so here I am. I'm going to tell you about testing smart intersections, and this is a really interesting project, but let's start about me. So my name is Guļbinova, that's my preferred name. And right now I'm covering QA in the Department of Software Development in LMT. And also in parallel I just have this side hustle as a teacher at Java Go as well. So I teach QA automation right now. And basically it's so nice to be here and to see so many familiar faces. And if you ever worked in one of these companies, you may have crossed with you or your colleagues. But yeah, basically, I started back in 2006, so it's about 20 years ago, as a junior QA. So I've done it all, starting from very beginning of QA. And right now I'm more focusing on the management, and mostly it's QA management, obviously. Right, so that was all about me, and let's start further. So basically this is a system that we are going to discuss today, and it's called Transport Monitoring System. So we automatically monitor transport, and I think you should be careful from now on, driving on the intersection and not do any violations, of course. So basically what we have on every intersection, by the way, any guesses of where this picture is coming from? What is the location?
Somewhere leaves.
Not really, a little bit far away. Cold, I would say.
Finland?
Better, but the other side. The other side wrong.
Norway.
Well, this is from Vilnius, Lithuania. So basically, we do have cameras on the intersections installed physically, as you can see. And these cameras are feeding the data into our system, into our servers. We also do have a web attached to it, so you can see all the violations coming in. And we also, of course, do have some integrations with third-party systems, which means we can automatically send you a fine via the traffic control agency. That's called, in Latvia we call it TSDD. Yeah, beware. Before I really tell you about the system any further, I'd like to touch the topic of the artificial intelligence in general. I know the public here is quite smart, and maybe we don't need this explanation, but in general, whenever we say artificial intelligence, we often think stuff like ChatGPT or maybe even Copilot, but in general, that's not the same thing. I would say that ChatGPT or any other text-generating tool is a part of that work, right? So it's called large language models, and generally it's just the very advanced Siri, which is just generating your next word, and that's it. But artificial intelligence in general is a little bit different. It's a little bit more than that. So we can train it. We can train it to do more than just generating text. We can do computer vision. We can analyze sound and stuff like that. So in this case, we do analyze video, right? So by the way, this picture has been generated by ChatGPT Moto 04040, but unfortunately, I asked it several times to generate also tails. It didn't work. So yeah, I generated them myself. I think they're quite pretty. The only thing that I don't like about this picture is that they're kind of fighting with each other. So yeah, I also asked it to make a friendly couple. The same issue with the tails. How many times I asked him to kind of, keep the tails in place? It will never do that. So artificial intelligence is not that smart. let's go back to intersections. So, any guesses about this picture? There you go. So we all see that we are all coming from Riga, so everybody guesses the VEF bridge, right? So it's over here. It's already functioning, so that you know. So basically, we do have like several cameras on every intersection. It's not just one camera. Usually it's 2 or even 3 cameras. Every single camera has its own like artificial intelligence robot. We put them all together into a box we call Edge, right? So basically they they work together and they generate the outcome, some sort of a data, which is also like a normal database, goes to normal database after that. So basically this is the smart part. That's what's happening.
Are you processing video on displays or sending raw video to some server data centers?
We do process some part of the video right on the intersection, but the magic happens in our servers. So we keep it ourselves.
Some kind of raw video?
We keep it ourselves. We don't share the magic, yes. So basically, about what we actually can do with all this stuff, what we can detect. One thing is the violations, of course. Sorry, violations. Right, so red light violation, obvious one. Red lights, no one is driving on a red light? Never? Hopefully. Another one is a bus lane. Bus lane is when you don't drive an electronic car, right? Electric car. You drive a regular car, and you should not take a bus lane. Forbidden turn, just like that. And also the interesting one, remain in the intersection. Also, maybe if you notice some issues with the, for example, the intersection next to our large office, where we, on the Guļbinova street, it's so large, and when traffic is high, some people are just staying on the intersection, so the opposite cars cannot go anywhere. So that's the violation, actually.
But on this intersection, you don't have yellow lines.
Sorry?
On this intersection, you don't have yellow lines which are forbidden to stay on as matter.
It's not me, it's not us, that we don't have, right? It's probably the question to CSDD, because they are the client, they dictate everything, so we provide, right? It's like smart distinction between responsibilities, that's the key. Right, so that's not everything we can do. We can also collect some statistics. And over here we can collect statistics about all sorts of different things and objects, including different types of cars, like vans, trucks, buses and stuff. Also motorbikes, distinguish bicycles and people as such. We also do average speed. We can detect average speed. And this one is has not been yet installed anywhere, but it's ready to go. And another one which fascinates me is the finding by number plate. And I believe this is a good one, right? So technically that means we can create white lists and black lists. Don't ever get into the blacklist. Don't steal cars or anything like that. So this is how it looks. Let's see. I forgot I had a button. So over here you can see red boxes around cars, around people, that lady, around the motorcycle. So we automatically detect them. Let's repeat maybe while I talk so that you're not bored. Right, so basically we have really low quality video, I would say. It's only 13 frames per second. But the reason behind it is that every frame needs to be analyzed, right? So we need to kind of slow down our appetites, and 13 frames per second is quite enough. That's why you can see it's a little bit, not as smooth as you would like on the YouTube. Right, so there is another example that we detect, the bus lane one. So I hope this car has blue number plate. Next one is the example of the bicycle rider. Then also this one is very good for detecting pedestrians, people around. How many pedestrians has been there, etc., etc. This one is an interesting one, right? So whenever you think of testing system like that, you think of all the tricky conditions that you would like to check. So basically, of course, something that comes up to your mind is like bad weather, rain, heavy snow, maybe dark, like night, dark conditions with no any like street lamps or anything. But there's stuff that you don't think about, like trailers. Trailers come in so many different shapes and sizes that it's so difficult for like artificial intelligence to distinguish. So basically, it's easy for us people, right? So we can take a look and tell whether it's a trailer or not. But for artificial intelligence, it's an issue. So this one here came up today. We never seen a trailer like that before. This is an easy one, just a heavy snow, nothing special. This we can handle quite easily, quite well. This is another one. For a person, it would be an issue finding out this number plate, but our artificial intelligence did it quite well. Number plates are covered, so for you not to find out who that was, right? It's all the GDPR, sensitive information protection, all sort of things, so we don't show you anything that you can misuse. Another one that you would never think about, nothing special, just a truck making a left turn, and you know, you can do it many times per hour, basically, but it will cover the whole thing. You don't see nothing anymore, right? So what do?
Place camera somewhere else?
One of the ways, actually. That's absolutely correct. But also placing cameras is also another tricky thing. I think I will tell you about that a bit later. I have another slide for that. Another example. This one has been detected as a bicycle. Right? But it kind of looks like a person riding something with two wheels. But also, as long as we teach the artificial intelligence, it becomes better and better every time. But we have to teach him, unfortunately. It's not enough to explain, and while like more uniform objects are easy to detect, edge and tricky cases are, you know, more difficult. This is also another one. I would never think of that one. You can see, what you can see is a bus and a windshield, right? And there is a reflection, and it's actually double refraction. So it's counted as two people, but in reality there is none, right? Interesting one. Even if you ask a child, they will never count this as a person, I would say, right? They will see it's not a person, it's a reflection. This one is quite a common issue, right? So we get a lot of them, and we have to teach artificial intelligence to kind of understand this is not an object, this is just a shadow, or this is just a shadow, right? He thought it was a motorcycle there. The one before was a car. Well, it's not. This one also, like an example of another project that we had. We were just counting basically motorcycles and pedestrians. Like we had to collect some statistical data about the flow during the day, whenever it's higher or lower, etc. And basically, this was an interesting one. It's not in Latvia; it's abroad, right? And basically, one of the examples that we got is this small part of the bush suddenly was detected as a bicycle for some reason. So we had to correct it. So we had to go and remove that bicycle from here. Sorry. Yeah. So there's a check I want you to see. That's why I get back. Right, so another example, over here, somebody was not detected at all, right? So we had to make it right. But also another thing, the person behind was detected as a car, right? So this is not a road at all. You can't allow cars in this place at all. So basically, it was a fun one.
But the car had quite low confidence score.
Yeah, it has, but it's been still detected. And as long as the score was so low, as you noticed, we had to remove it, right? So we removed it at all, and we corrected the bicycle and the person on top of the bicycle. So that was the correct version. This is another example of some object, I would say. Do you think it's a pushchair or a bicycle? What's your guess?
Car or bicycle?
Car.
Or a pushchair? So we have a division here in the audience. So it's a bicycle, right? So we had to guess sometimes, and we had to kind of watch a longer footage to understand sometimes. And here are a few more examples. This is a bicycle, obviously, right? Have you ever seen a bicycle like that? Right, so some boxes and a roof, nice. Another pushchair, this is not a bicycle, although it looks like the one before, right? But it's not. Yeah, and this is just like a picture full of different types of bicycles, so we have to detect all of them. Another one, smaller one. Okay, it's the darkness, it's fine, but we almost don't see no wheels, but we have to detect it as a scooter. So, all the different challenges that we face. And this is a really fascinating one. So basically, this video, it's a video, I promise. This video will show you how, what is the reason behind basically inventing all these intersections. You see the light changes, right? By the way, this video was published by the mayor of Liepāja, so I have the whole right to show you this, right? Because this video belongs to the client. So did something happen? I think we missed it, right? Oh, it just happened, right? So you've seen that guy didn't even try, right? And the mayor said that he checked the statistics and there was 262 red light violations in 1 month, in the first month of their work. The interesting thing though was that, okay, after a few months they said, okay, we have reduced the amount of violations now. Can you move the intersection to some different place? Right? And they challenged that, of course we can, no worries, yeah, it's job, we can do it. But the issue is, every intersection is unique. Every intersection is different. And we actually have to train our camera for every intersection. So it's not just moving. It's like setting up from scratch, right? So that's what clients don't always understand. Okay, so what else we can do? We collect some statistical data, and over here it's like really nice. You can see tendencies, and you know, it's nice. I love graphs, obviously, right? So you can tell. Basically, on the very top one, you can see the tendencies to reduce traffic during the weekends, of course, especially Sundays. And over here is a Easter holiday, right? So you can just see it right like that. The second one is during the 24 hours. So the morning traffic jam, this one. That one is an evening traffic jam, from 5 to 6. and the nighttime. Interestingly, if you look at the bottom one, these are violations. They actually like kind of repeat the top graph only on the 1 week basis. So you can tell that, you know, 17th of April it was Friday, right? 40, and so on, so on. So the more traffic we have, the more violations, which is kind of expected behavior, isn't it? So let's talk about testing finally, as long as this is a talk from the QA, right? So what's special in comparison to any other system testing? If you just test a regular one, any QA's job is full of surprises, full of interesting stuff. But what's special with real life system one? So one of the most important things, it's so difficult to recreate scenarios. So difficult. You can't go and make another violation, don't you? But there are ways. Very difficult ones, but there are. So one of the ways is to try to find that video chunk and feed it into your local machine. But your local machine must have all the, you know, all these robots installed, which requires really like strong machines, and QAs don't really like have them anymore. Not anymore, but never have them, unfortunately. So that's why our QA people, they must work really close with developers. So it's more like a pair programming, pair like kind of analysis. So communication becomes essential here. We can't really divide our team into separate QA team and development team. We have to work together. Another way how to recreate some of the situations is to adjust configurations on your intersection. The thing is that we can just go and configure, let's say for example, move your stop line a bit behind so that more you know, red light violations will be triggered and you will get more data coming into your system, because only the violations are coming, all the other data is not.
You mean the real stop line, or
of course
sort of
not.
internal
I'm telling you about configuration. Of course you don't go to the street and don't draw, you know, take a paint and draw another stop line. No, you can do it, of course. Of course, be my guest, but we don't do that. Yeah, another issue is that there are many really weird things happening that you can't really predict. Stuff like, for example, sun path on the sky, right? It's so difficult to predict how it's going to change over the course of the year, because it changes, and sometimes it will reflect into your camera and you won't see nothing, right? We also had an issue with the branch. I'm not talking about CI/CD, right, or any code things. I'm talking about the true tree branch, which just grew into the camera, right? And we weren't able to go and just cut it, because it belongs to some city. It belongs to, you know, it has all the rules around it, all the bureaucracy. So this is where monitoring becomes essential. So our part in it, we have to monitor, and we have to let them know that something is wrong, and that's our part ended there. So in real life, they have to call this tree specialist, who's called arborer, I believe, and they go and cut the tree correctly so that it's alive and thriving, and then, yeah, so interesting. I never thought of that before I started working on this project. And of course, another issue that we have as testers, as QA engineers, I would say, rather, right? If there are any QAs there, they understand the difference. So a lot of new intersections, like plenty, and we have to test them all, because as I said, they all are unique, all are different, and each and every one requires like a separate setup, separate testing, so that's an issue. And the issue is too much work. We do have too much work. So we tried it all, I believe. We tried to delegate intersection testing and other testing to business analysts. We hired new QAs. What else we did? Like we did all sorts of things. We tried to reduce the testing amount, like everything we could. But in reality, the best was delegation. So we had to delegate this work because the amount of intersection grows exponentially. And this year, we plan on installing more than 20, I believe 28 intersections in Riga. So it's just Riga, yeah, because we also work abroad. So be careful. Basically, delegation seems like an easy task, but it's not. So first of all, in order to delegate, we had to describe the process. So real step-by-step to first understand the process, right? Then describe it. Then we had to define actors, who is going to do what on each step, which was not a straightforward task as a surprise. Then we, of course, try to find ways to speed up the testing, because as long as we said, okay, every intersection we need 2 weeks to test, our business came back and said, okay, we don't have that time. 2 weeks per intersection times 28, we don't have that time, right? So we have to reduce it. Okay, the next one, we had to describe the process. That seems like an easy task also, but you need to keep in mind that we want to delegate. We want to delegate to somebody who never done that before, who don't know what they're doing actually. So it's going to be a description that's really easy to understand. And also, that's not it. We had to test our description, right? Test everything. Test your tests. Guard the guards. So we had to test the description. So how do we test the description if we know too much, right? How we can understand, people will understand it. So we had to delegate internally. First of all, that was our first step. So we tried to find somebody who knows the least about the intersection and delegate to them. And then test our description documents. And we did. And basically the next step that's still ahead of us is to delegate finally to basically anyone, to any technician, any, I don't know, maybe support specialist, anyone who's not even related to QA, so that they can help us. Right. So again, let's talk about intersections. They are unique, and not just in the shape as this picture, but also the rules. Some intersections have bus lanes, others don't. Some intersections have 3 lanes, others have 2 or 1. They all are so different, and basically that makes it more difficult also for artificial intelligence to understand and for us to configure, right? So even more challenges that we face, regulatory and reputational risks. As long as we go abroad, we need to provide quality project, right? So it's quality becomes essential, and we cannot allow for really nasty issues. So we have to test it really well. At the same time, we do have changing environment, and our business said, okay, our requirements are changing, and we have to adapt at the same time, which is a challenge to, to think, just the 2 things at the same time is a challenge. And another challenge that we had was the accuracy calculations. The issue here is that every client, almost every client, they come and ask us, give me a number, just a single digit, not a digit number. How accurate are your tests? And how do you calculate it? We can apply mathematical statistics to artificial intelligence and guess the accuracy with some sort of percentage, like 98.27. But will it be real? Me as a QA, I say I don't know, right? I am Curie, I never believed. So in order to really truly calculate what I would do, I would go sit on the intersection for a year, right? Because I want to get it all. I want to have like all different sun paths. I want to have all different weather conditions, all the different, as much as possible, different situations, and then compare it to the, artificial intelligence output. Of course, it's not, unfortunately. It would be a fun job, right? But it's unfortunately not realistic, so we don't do that. That's why we use fine print, and we say, okay, this has been calculated with this and that condition, like feeding in prepared videos that we know the output for, or measure it at the sunny conditions with this or that traffic, etc., etc. So, lessons learned. Artificial intelligence is not going to overtake the world. That's the lesson that I learned, right? Artificial intelligence needs to be taught, I think is the correct form, right? So it's not a kind of magic. It needs to be controlled and guided. Another one is that no one can possibly predict every scenario, all the situations. So we have to be as much as we can, be good as much as we can. Every intersection is unique, as I repeated many, many times, which was not as obvious at first, and that mistakes is a part of the process, and that's something that you can take out to your personal life as well, right, or your career path, anything. Mistakes is a part of the project. Mistakes can help you learn, help you become better, just in a way as, artificial intelligence, like detecting a bush as a bicycle or something else. And of course, which is, I believe, the most impactful issue with any company, any team, is the communication, especially cross-team. That's the important stuff and important thing that you have to keep an eye on at all times. This is just a bonus slide. So basically, I can show you this slide really bravely because with no fear about the sensitive data, because these guys actually have generated faces. They're not real. So this is the next feature that we are working on right now. You can tell, you can see a bit closer. So they really look very natural. They really look like they are these guys, but they are not. So this is something that we want to implement during the next maybe year or so, like anonymizing data from for regular people, so that we can easily share this data with whoever the client wants, not us. No, we don't. So future. We do see Latvia as a trampoline, and right now we also we do have several projects abroad as well, and we see that the interest is really high. Systems like this are not too popular around the world. I'm not saying they're non-existent, but the demand is higher than they can provide. So basically, it's a really good time to go abroad, and we are doing that. We plan on much more new interesting features, right? We want to export to all of the place, and there will be a lot more intersections. There you go. Thank you.
There are questions, right?
Yes.
Oh, sure. I don't know the rules.
It's the first time I'm here, I don't know the rules.
So the rules are you have to answer all the questions. So the first
That's the
question
fun
is
part.
what what is the procedure for me to get in the list of untouchables?
You have to go to CSDD. That's a good start, isn't it? Okay, you can figure it out. Please.
Maybe we're working on some system which will monitor traffic and dynamically adjust traffic lights.
That's an interesting idea. I will pass on to our business team.
So it will be very useful for our city at least.
Definitely will do. Yeah. Please.
Yeah. So have you had some issues with working as a QA with masked data? Like it's usually an issue, like you have production data and then you're trying to like use it maybe in lower environments. Could you maybe share some experiences around that?
Not sure I got the question.
The anonymization part, right?
Yeah, okay.
For private persons. So that's essentially masking, as we saw a lot of people with blurred faces. Or do you have something like QA issues around working with masked data instead of real one?
Well, we do. You know, we don't really mask them for internal work. Right, so I believe this masking faces is the huge step into that direction that we will. For now, the legislation is not as clear what we can do, what we cannot do, so we kind of use it in order to push this technology forward, because otherwise we will be just, staying behind. So in terms of testing, every environment, also testing environment, has their own intersections set up. So we can't use the production intersections, but we do use the testing one, which also obviously has some traffic with real number plates, for example. So we do use them, but it's not going anywhere out of the team for sure. It's real life data.
Cool.
Somebody from behind, maybe? Girl?
Louder, please.
Please, yeah. How hard for me is to make a custom paint or print on my car so it won't be recognized by AI at all?
That's an interesting question. You can just cover your number plate, I believe, with anything that you like, and it will not be recognized as a number plate. But, good luck.
Painting like a bush.
Paint a bush around you, yeah. So actually, there is a good answer. I know there are people who are trying to abuse these automatic face recognition systems and people recognition systems. They used to wear special jumpers with some noise, painted all over them, and the system wouldn't recognize them. But I believe the system became much smarter since that time, so they still recognize them now. So it's getting harder and harder to abuse the system.
No secret car service business.
Sorry. What else? Please.
Yeah, I got a question regarding the special cases, which in my opinion are not edge cases, like police cars, firefighters, etc. They can not obey rules of traffic sometimes, and does the system handle this case, or it's like just left for humans to sort it out?
Well, as I said, I believe this is a case for the whitelist. I know that what you mean is that sometimes they have to follow the rules, sometimes they can make violations, but I believe that's for them to decide whether they are, following the rules or not. But like you can add or remove them from the whitelist, I believe, right? So this could be handled by a client, and they could do it dynamically, I believe, but that's just, I'm guessing,
Thanks.
Okay, so somebody from behind, please.
How is the monitoring of non-detection happening in your system?
Monitoring of
Non-detection of either vehicle or other object?
Yeah, well, as I said, our systems are you cannot get 100%. It's impossible. You can't. It just doesn't work. Sometimes you have a truck covering the whole intersection, and so you don't see somebody behind. Sometimes you have really nasty weather conditions with snowstorm at night during the wind. I don't know, and it just you don't see it. Like, you know, these systems will work a little bit better than a human eye in terms of detection number plates in really bad weather conditions, but they will not recognize 100%. Even if the person, you know, you wouldn't see sometimes, just because it's physically impossible.
I guess
So,
the question is more about trends. Like if it started to generate false positives, you would spot it because people will complain for their false tickets. But negatives,
well,
nobody complains, right?
about that, I know there is like human control on the client side, on the like this traffic agency side. So in case they receive the violation, they will always go through again. Because sometimes it can be a gray area, tricky case that has been triggered, but it's almost not a violation, for example. So there is always a double check
So
on
the
that
positives
side.
are easy to control, the negatives are
True,
not possible.
I agree. Yeah.
Again, you mentioned that you're receiving only the violation data, meaning you do not receive full data. And there is no violation, there is no data, there is no chance to correct non-detection.
It's like it depends on the goal, because sometimes we do have all the data. Like for example, with statistical data that we collect, we try to receive everything. In terms of violation, it's like yes, of course, in our systems we only see violations, but the artificial intelligence is going through everything. That's true, and yeah, sometimes it's hard to understand what they are missing. Yeah, I hope I answered to some extent.